Hi, in this tutorial we have a question related to radical polymerization. The question asks us what polymer is formed from each monomer. The polymer from butyl alpha cyanoacrylate part B is used in the topical skin adhesive liquiband, and vinyl pyrrolidone part C has been used in the manufacture of glue stick. Let's start from option A. Generally, we have to decide what part will be polymerized in a molecule and what part will be the substituent. So in this molecule, this part is the aromatic part, and we can label this one as a substituent, and I prefer to call it Z. So here we have an alkene and ethylene part. So if we reduce this structure to this type of polymers, or this type of monomers actually, so we have a pi bond with an ethylene, and it has a substituent Z. When you do the polymerization, let's say that we can polymerize 3 or 4 units, or you can maybe make it more. So again, I am placing the substituent here. There was a pi bond before, but when the polymerization start, this pi bond will be broken, and an initiator will be added from this side, basically from this part, and the radical will be formed. Another radical will be formed here, but this will add to another monomer, so it will keep repeating like this. So you have to add repeating unit, and we said we can have 3, 4, 5 monomer units added together. So let me say we have 5 monomer units added. So I have to draw here 5Z, 5 repeating units. And then we have to end here. So basically, you can start from this part and you can end in this part. So we have here 5 repeating unit. So the substituent, what is the substituent? The substituent is this part. So we can just replace these Z's with the substituent. So I'm going to like substitute some of them, not all of them. So basically, this is a nitrogen and part of a ring, 5-membered ring here. Then here we have a benzene ring. And you can just draw the other parts. So there is another question sometimes, like why these pi bonds do not polymerize? That's a good question. The answer is these pi bonds are part of the aromatic system, so they don't polymerize. They are not reactive for the polymer reactions. So that's the reason. So the only alkene part here is reactive. Okay, so again, like let's also like add some more monomers. I may not have enough space to draw, but again, this 5-member ring, then 6-member ring here. So I'm just drawing the pi bonds here. Let me just do one more part here. I have space there. So it's a nitrogen. It's part of 5-membered ring here, and here we have the benzene ring. So we can add pi bonds here. Okay, so basically, again here, the same structure. So this is the structure of polymer. Basically, like you can draw here more repeating units, but generally people draw one repeating unit, let's just do it that way. So again, like, so it's Z here, okay, here and here. So people generally put a parenthesis here, say and, like many repeating unit. It can be 1, 2, 3, 4, 5, but in the polymer reactions generally this is like more than one, and it should be ideally like 10, 20, 30, 40, in some case hundreds. Okay, let's also try option B. Again, we are going to do the same approach here. So basically you can say we have a pi bond and a Z, and here Z is basically instead of Z we have here another part, let's say that is X. So you can say this is part Z, and you can say this is part X. Again, when we do polymerization reaction, again, start putting here like the Z and X here. Then you can repeat this process many times, and I'm going to just place here another Z, another X, here another Z, another X. Make sure that there is like a connecting carbon, like, because when you do the polymerization, you are forming a new bond between this pi bond and another pi bond, the same molecule. So again, we can replace the X and Z's with the group. So X was the cyano group, it's a CN part. So let's just write it here, CN. For the Z, again, let's just erase this one and let's place the proper group here. It's this part, so there should be a carbonyl oxygen, then the ester part. We have 4 carbon, so you can 1, 2, 3, 4. Basically this will be repeating. Again, we can just add one more. Again, this will be cyano group and this will be the ester group. 1, 2, 3, 4. So it will keep repeating. I'm not going to like label each one. Let's also do part C. Again, here we have just one substituent here, which is Z. Again, let's do the same. So Z, and when we polymerize it, so let's add a couple more Z. Okay, I will stop here. So instead of Z, again, we can just place the group, the real group here, which is this pyrrolidone ring, which is, there's a nitrogen here, and it's part of 5-membered ring. And there's a carbonyl here. I'm going to do the same for this repeating part. There's a nitrogen, it's part of 5-membered ring. There should be a carbonyl oxygen. You can do the same for the Z. So make sure that like you start from here and you end here. So that's the repeating unit. But again, you can also do just one repeating unit. So we can do it that way. So this is the pyrrolidone ring. There's a carbon here, so I will place from here to here. So let's say this is N. Okay, thank you so much for watching the video.